So guys, now let us discuss in totality that how CPU actually access physical memory. So in this slide you can see that there are three devices: the CPU, MMU and the physical memory. Now we have already discussed that CPU generates logical addresses. Logical address means virtual address. So let's say for example this logical address is 156, right? We have just chosen a random number which represents logical address. Now MMU is a hardware unit which converts each logical address into physical address. So let us say in our example, MMU converts the logical address 156 to 56. So 56 is a physical address. Now what is the science behind converting logical address to physical address? That we will going to discuss later when we will be discussing the concept of paging. For now, just understand that MMU has converted logical address to physical address. We have arbitrarily chosen this value of 56, which represents a physical address. Now, there is an address bus between MMU and physical memory. This address bus connects the MMU and physical memory using 32 metallic wires. Why there are 32 metallic wires? Because we are discussing computer architecture for a 32-bit systems, right? So for a 32-bit system, the address bus will have 32-bit lines or 32 metallic wires. Now we have assumed that the physical address is 56. The voltage levels on these metallic wires of an address bus is set such that physical address 56 is represented by the equivalent binary encoding derived from the voltage levels on these 32-bit lines. So you can see that this represents 56. Now 56 is a memory location of a byte in a physical memory. So whatever value we set on this 32-bit address bus, corresponding to that memory location in a physical memory is accessed. Because in this example the physical address is 56, therefore the address bus will map to a memory location whose physical address is 56 in physical memory. Now once a particular memory location in a physical memory is identified, CPU then issues read or write operations to be performed on those physical memory locations. Now until this point, CPU has identified the memory location in a physical memory on which it needs to perform read or write operation. Now to facilitate data transfer between CPU and physical memory, there is another bus called data bus. So you can see that in this data bus there are 4 buses, that is bus 0, bus 1, bus 2 and bus 3. Each bus in turns carry 8 metallic wires. It means that each bus carry 8 electrical signals corresponding to 8 bits. It means that each bus read or write 1 byte of data from physical memory, right? Since there are 4 buses, therefore data bus can carry 4 bytes of data from CPU to main memory as well as from main memory to CPU. So bus 1 also carry 8 metallic wires, bus 2 also carry 8 metallic wires and bus 3 also carry 8 metallic wires. So total of 32 metallic wires. So on a 32-bit system, the size of address bus is 32-bit lines and the size of data bus is again 32-bit data lines. So you can see that CPU can perform read and write operations on a physical memory of 4 bytes in total in one CPU clock cycle on a physical memory. So why CPU can perform read or write 4 bytes of data in one CPU cycle? Because the size of the data bus is 4 bytes. So you can see that in this example, CPU identified the memory location number 56 in the physical memory. And CPU wants to read the values present at address 56 and address 57. Let's say, for example, CPU wants to read 2 bytes of data. So whatever data is present in these memory locations, that is on memory location number 56 and 57 in physical memory, the same data is then pulled on these data bus wires, right? So you can see that since the CPU was interested in reading the data at memory location 56 and 57, therefore whatever data was present at memory location 56 is set on the metallic wires of bus 1 of the data bus. And similarly, the data or the content present at memory location 57 is set on metallic wires of bus number 2 of data bus. So from this diagram you can understand that CPU can read maximum of 4 bytes of data from the main memory in one CPU clock cycle. So going by that, suppose in your program you write the following statement. Now let us assume that long data type is of size 8 bytes. So it means that we are trying to copy 8 bytes of data into a memory location identified by variable 1. Now on a 32-bit system, CPU can perform read and write operation of 4 bytes in one CPU clock cycle. Therefore, in order to copy 8 bytes of data into this memory location, CPU will have to perform write operation in 2 CPU clock cycles, right? So CPU will take 2 CPU clock cycles to store the data in a physical memory on a 32-bit system, and if your system was 64-bit operating system, then CPU would have taken 1 CPU clock cycle in order to perform the same operation. So data bus actually defines how many bytes of data CPU can read or write into the physical memory. So for a 32-bit system it is 4 bytes, and for a 64-bit system it is 8 bytes. So this is how address bus and data bus collaborate together to facilitate communication or data exchange between CPU and physical memory. Now I will ask you one question. What is the maximum address the address bus can carry? Now address bus has 32-bit lines. So on each line, even if you set the high voltage level, so the maximum value or memory location that address bus can carry is 2 raised to the power 32 minus 1. It means that CPU can access the byte number in the physical memory whose address is maximum of 2 raised to the power 32 minus 1. Now we already know that 2 raised to the power 32 is equal to 4 gigabytes. So it simply means that if you try to install physical memory greater than 4 GB on your 32-bit system, it is absolutely useless thing to do. Your CPU can never access a memory location on your physical memory whose address is greater than 2 raised to the power 32 minus 1. It means maximum of 4 GB of RAM you can install on your 32-bit system. If you try to install RAM which is greater than 4 GB in size on a 32-bit system, the memory locations beyond the address 2 raised to the power 32 minus 1 will never going to be used by CPU and it will remain unused. So it is for this reason that today we have 64-bit systems. On 64-bit system you can install physical memory of maximum size 2 raised to the power 64 minus 1 bytes. Now this is absolutely huge. So this is interview question that why on a 32-bit system you cannot install physical memory beyond size of 4 gigabytes. So I have a little advice for you. You must learn these diagrams throughout the course in order to explain the concepts in interviews. So you must have this diagram in your mind so that when you are asked the question, you can draw the same diagram on a board or a paper in order to explain the concepts to the interviewer. So I advise you to just not listen and understand the concept, but rather practice the concept by drawing it on a piece of paper so that it will stay persistent in your mind and you can explain it clearly to the interviewer. Many a times I have realized that students knows the stuff but they are not able to explain it because simply the student have not practiced to how to explain the stuff to the interviewer. So take it as an advice to practice all these concepts by drawing once on a piece of paper.